Okay, see 495. All right, next step. So we're gonna just expand our learning of ETABS 30 by 40 feet. We studied last week. I hope you guys get kind of familiar with just beginning the ETABS, the how to draw, start out the setting the unit and grid, the floor elevation, and the section property, material property, and draw the column, girder, beams, and slab, and assigning loading analysis. So those are all similar. Most of project, all project, we are doing the same thing over again. Yeah, this is not at it's not only pure engineering. I mean, drawing geometry needs something rational, the skill, so that once you use it more and more, I will see you're gonna learn a lot. All right, so here today is gonna get started a little bit. I'm gonna show you more building floor plan scale. So here we're gonna start out similar template. All right, I'm gonna just use maybe 6 bay, and the Y direction will just keep it 3, and S direction the column spacing 30, and the Y direction 45. So I keep it 30 by 40, right? Building floor to floor height, I'll just keep it and just grid. I'll set it up number of story full floor. It's all right. So, but obviously in the real building, the grid is not always uniform in X and Y. So I'll show you some adjustment. The first in edits here, edit story, since we kept the 4 number of stories, you'll see that every typical floor to height is 12 feet, and number of story 4. So you see that all building story height and elevation information here. I think if you want to edit, you could edit here by clicking, right? Or you can adjust the floor to floor height by typing here, right? So obviously this is kind of no-brainer, easy. Now grid, speaking of a grid, here we have a grid system default following X and Y, Z coordinate system global. So when you open it, you see the X, Y coordinate, right? So in X direction, we're gonna keep it 30 feet, right? Spacing. The Y here is coordinate is at, since we choose 45, 45, 45 instead of 45, 45, 45, I'll just change a little bit here so that I'll adjust it. So interestingly, ETABS has some built-up the feature. So there's a calculation there. So you can type it and you can adjust the grid system. So I'm gonna go back. Okay, right. Okay, so this is the example. Similar, but we're gonna draw entire floor framing layout with a concrete show wall, right? So the one thing as we learn, we're gonna start out with the column. So I click the quick draw column, and if you hover around and click intersection of grid, but also you can just drag and drop and add a column you wish to add it, right? You'll see that all the column was added. By the way, let's move this, remove it. I'm gonna go down to story 1. Basically, it doesn't matter, but you need to assign the boundary condition manually. So story 1, I'm gonna click the column. I'll choose a lateral column, and drag and drop, and drag and drop. So I add a column there first, right? And second, this time I'm gonna draw the wall. So this wall, I think it's the same thing. You could draw the wall like this, which is quick draw, right? Or you could still use, click the grid so you can draw this. Later on, we're gonna adjust the wall. But for today, I'm gonna click this. I'm gonna just drop the wall, totally close the wall. Then the reality is we need to make opening there so that the people can walk in to use elevator right? So, but in reality, it's not gonna be solid in a closed wall. So now, second one is okay. As we learn it, you could do, you can click. You can maybe do this, but yeah, because you add a beam here, so you could just draw and or click this. So you draw the girder which tying the two adjacent column. Here, since we have a wall, we don't need a beam. So here you can see it when you shrink it. This is still when you shrink it. When you shrink it, right? You see that the concrete wall, shear wall, and column and beams are there. All right. Now, next step, we already learned it. Here, quick secondary beam draw, right? Pin supported since 30 feet. We're gonna use the two beams so that the metal decks will span 10 feet span, right? So since grid is well set it up, you can just move your cursor and drop the beams. So make sure that all the beam is the moment release. All right, so let me just this checkbox. So how do I know this is moment release or moment connected? So here, second tab, object assignment, there is an end release. So when you, why this graphically slow? Okay, let me just checkbox. Yeah, end release, apply. Yeah, I think it's, yeah, it doesn't automatically refresh the two. You see that all the dot is showing here. Maybe to activate this, show this. It's graphic issue. Here you see the all the dots in the beam. Let me just rotate, move this, and choose the story one. Turn on and release. Say okay. Okay now, and so you see that. I think maybe I'll close one window. So all right. So where we are now. The one thing that I want to make sure is we're gonna learn composite beam floor framing. So old even girder, I'm gonna release the moment so that we can design all the beam as a composite action. So I select all the beam, which when I draw this, I didn't choose the pin moment release, so it doesn't have a moment release pin connection. Now I'm gonna go assign. I select all the girder that I want to assign the moment release here, right? This is a release partial fixity. Most of the beam is working for vertically, so I release, apply the moment release at each end. So what you see is all the dot is a moment release, simply support beam. Even though girder, because of we don't have any fixity, it work like a simply support beam. You'll see later during the analysis and the moment diagram check. All right, so we mostly done drawing all the column, beam, and wall. Now, second, we're gonna draw the metal deck, which I'm gonna redefine the deck section properties. Go to define and deck. The default is 3 inches, 3.5, so I'm gonna make 4.5 inches. This is normal weight concrete. So again, always name convention, metal deck, normal weight. So field is a solid metal deck with a concrete slab. I choose default 4000 psi concrete. Metal deck has a yield strength 50 grade. So eventually total height is 7.5-inch slab. So I change that property and then drag, hold it, click and drop, right? So if I refresh it, you see the orientation. the metal deck orientation should be perpendicular to the beams, right? So no brainers. So now what I did see, maybe good to aware of it, because of in realities there will be more slab overhang over the beam and column, which you could select the slab and go to edit shell, and you can expand, maybe let's say 24 inches, let's say. Hmm? Okay, because it's a shrink. Okay, here. So you see that initially we draw the slab by picking this intersection points of the corner, but I just expand this plate by 24 inches. So this is great expansion, the overhang. So eventually in real building, we need some slab overhang. So the curtain wall, right? Exterior curtain wall will be attached to around this overhang slab. All right. So we just complete the geometry. Okay. Now next step, again going define, we're gonna set it up the load cases. For future composite beam design, I'm gonna set few more load cases. So first of all, that load is self-weight of structural element. Again, structural element, column, girder, beam, and wall. So ETABS will automatically calculate their self-weight. And superimposed that load we've been discussed. The building need more some stuff on top of structural elements, which ceiling and duct and the lighting, right? And then floor finish. So this is those kind of load is when we attach, it's gonna fix, but it's not structural element. So we'll treat as we can assign as a load. And live road is a live road, and there is another construction, that construction live road. I'm gonna add it as part of construction, the load type. So during the construction of this composite floor framing, there is the two step of construction and the permanent, temporary and permanent load condition we need to consider for the design phase. Okay. So what I'm gonna do, I'm gonna start assign the load, shell load, uniform. Self-fed is, I'll just keep it as it is, and SDL is all flow finish and some MEP loading. I assign the 20 PSF for gravity load direction. If I want to click again, live road we've been discussed. Maybe this case is 100, right? And then right click again, and construction live road I will assign 20 PSF. All right, so I assign the load. So if you want to make sure you assign properly, you click the slab and right click. Okay, there's 3 tabs: geometry tab, assignment tab, and loader tab. You'll see that STL loading, live loading, construction live loading. All right, so this is 3D ready. Why don't you run? Why don't we run? Okay, so that is floor system. Okay, let's see. Okay, so when you run the analysis, the ETABS always show default data displacement. You don't have to worry about now. This is just graphically show the deflection shape, but at least you should pay attention that, okay, every element and loading and associated deflection displacement is makes sense, because gravity loading, right? That load is self-weight is loaded. The beam is deflect vertical down. Slab is also the deflect in the vertical down, right? So it's kind of common sense. You always double check when you assign, and the loading and all your model should behave based upon your expectation, right? So here, so now just the one information, since grid is still bothering you, then Control D. Yeah, you can turn off the grid. Control D, you can turn on and off this grid. Now, same thing that we're gonna check the bending moment diagram. right? So either using shortcut, member forces, or here display force, frame, force. You could, yeah, those are same. Obviously, this is shortcut I'm using it. So first, dead load, right? Dead load. Oh, one thing that what, okay, so we are checking the bending moment diagram. So what you can see, most of beams behave like a single beam, right? It's a single curvature moment diagram, but somehow you see that beam has a negative moment, which means I think I didn't release the moment. So this color, right, doesn't have a moment release each end. So it's showing positive moment, which is yellow, negative moment in red, right? So what you need to do is always just check and validate your model. It's kind of common sense, using your common sense and your understanding. So you need to make sure your model properly, everything is set it up. So I'm gonna go and I'm gonna check this, right? See that? Okay, I didn't select. So I'm gonna select this coder, which I didn't assign moment release. Okay. Okay, now go to assign frame release. Okay, both ends. I'm gonna release the moment. Oh, I missed this one too. Okay, seems like every beam encoder has a moment release. Okay, I'm gonna run the model again. So this is very important. It's no matter what. Okay, always when you create the geometry uh, and then assigning all the loading after analysis, you should go through and make sure your mod input is makes sense, right? Yeah. All right, now what you see is a moment diagram under that load, which is same direction, live road, right? It depends on their magnitude, overall uniform load effect, but you see that all the moment diagram curvature is single curvature, right? Simply works like all the beam encoder work like the simply support beam, okay? And show force diagram should show same thing. You see that? This is actually the basic, the beam, the analysis, then your, I think, structural or steel class will teach you. So this is what we've practiced a few times. Now you should be able to calculate this maximum middle span moment based upon your uniform loading times tributary width. So that WL square over 8, right? That's make you can calculate the maximum moment at the middle span, right? No, okay. Before I close it and next and move to the composite floor framing design, I'll just show you that ETABS has some good feature. So that load combination we need to set up, since we follow uh, load name and load type, then ETABS gonna help us to set it up load combination very quickly. So here in the load combination, add button. So I'm gonna choose composites beam design, right? It's because we're gonna design the beam by using composite beam design. So when you click this, it generates all the load combination, especially S1, okay, is 1.4 dead load, S2 is 1.2 dead, 1.6 live load, right? So this is ultimate error rapid load combination. But also it check the phase one. I'm gonna just explain the composite floor framing design because of this, because of construction sequence. We need to check the beam size and their behavior under their temporary during the construction phase. So this is C1, C2 is gonna be used during the construction, basically before the concrete get cured. And we'll talk about a composite floor framing design later. But this is a kind of load combination you need to set up before you run the composite beam design. So once load combination is set, obviously we have some design module here, so you can run the composite beam design. But one thing I need to show you, let's see, in this floor, and I'm gonna check, turn on the section property. So since while I'm designing, checking, drawing the beams, I somehow selected, okay, a lateral beam and a, so section property a composite beam or a lateral beam, right? This is auto selection, group of auto selection property. So when you go to frame property, you see a composite beam. So here is auto selection section properties, so that engineer usually you have some preference that the beam sizes, typically here default W10 to W36, you include it, so that while you are running the composite beam design, it will choose appropriate beam sizes for your the framing. Same as the lateral beam. Yes, the lateral beam is more heavy duty, so I think you see that more heaviest member sizes are included in auto selection. So I'm gonna just stop here, but I think I'm gonna just treat every beam. Just I'm gonna use for now for, I'll select by, let's say, object beam. I select all the beam. I'm gonna for now throw out to the auto composite beam. So next video I'm gonna show you how to run composite beam, and we can uh, com confirm the or learn how composite beam design works in ETABS. Okay, great.